Hey guys, Mr. Miller here. Today we are going to learn about mean absolute deviation. And we use the abbreviation MAD, mean absolute deviation. And what that is, it's the average, that's where we get the word mean, the average of how much data values differ from the mean. So how much they deviate, so how much they differ. So I have some steps written out. Step 1, you calculate the mean. So we find the average of the data. Step 2, we find the distance between the data value and the mean. So in other words, we just subtract. I'll write that out. We'll subtract each data value from the mean that we come up with on step 1. Then on step 3, we add the numbers from step 2. So each of these distances, or the differences. And on step 4, we calculate the mean, or the average, of those numbers. Okay, and I will walk you through a couple samples, and hopefully this will make some sense. So, again, mean absolute deviation. That we're trying to find out how much each number deviates from the average. So what we're going to do is we start out, step 1, we calculate the mean, which means I have to add all of these numbers. We got 2, 4, 6, 8, 10 numbers. So I'm going to do it over here. I'm going to write 78, 56, 99, 102, 90, 88, 80, 60, 55, 42. So I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, got all 10 of them. I'm going to add all this up. Oh boy. 8 plus 6, 14, 23, 24, 25, 33, 34, 35, 36, 37, 38, and I'm 40. Carry my 4. 4, that's 11, 16, 25, 34, 42, 50, 56, 61, 65. Carry my 6. 6 plus 1 and 7. So I add these up. I got 750. Now, we have to find the mean, or the average. So I'm going to divide that by 10, because there's 10 numbers in the set. And that comes out to 75. That's a little mental math. So 75 is our mean. Now we have to find out how much each of these individual numbers deviate, or the difference, from the mean. So I'm going to go through each of these. I'm just going to write it off to the side here. So 78, that is 3 away from 75. 56, so I subtract 56 and 75. Let's see, 66, 76, that's 19. 99, let's see, 75, 85, 95, that's 24 away. 102, let's see, that's 25, 27. Difference. 90, that would be 15 away from 75. 88 is 13 away from 75. Again, all I'm doing is subtracting each of these numbers from our average, 75. 80 is only 5 away. 60 is 15 away. 55 is 20, because 65 is 75. Let's see, 42, oh boy, 25 plus 8, that'd be 33. So, once I get each of these numbers, I'm now going to take this and calculate the mean, because we're going to find the average of what each number is away from 75. So, here we go. I'm going to add all these up. 3 and 9 is 12, 13, 14, 15, 16, 23, 28, 31, 36, 41, 44, carry my 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I get 174, but I still have to find the average of that, divide it by 10, because there's 10 numbers in the set, and I get 17.4. So my mean absolute deviation is 17.4. what that means is each of these numbers on average is 17.4 away from 75. All right, let's go through sample number 2. I know that was a lot to take in. I'll do it in green this time. So, again, what we do is we start out by calculating the mean of the data. So I'm going to write all these numbers out. We got 10, 8, 13, 12, 7, 10, 12, 11, 9, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got them all. All right, now I'm going to add all these up. 8 and 3 is 11, 12, 13, 20, 22, 23, 32, 35. Carry my 3, 3, 4, 5, 6, 7, 8, 9, 10. And I get 105. And I have to divide this by 10 because there's 10 numbers in the set. And I get 10.5. Oh boy, this is going to be really fun. Now we have a decimal to deal with. So, the mean is 10.5. And again, we're trying to find out how much each of these numbers on average deviates from the mean. Okay, fortunately these aren't real big numbers. So I'm going to go ahead and I'm going to do this in blue. So I'm going to go through each of these numbers and find the difference from this to the mean. So 10 to 10.5 is only a 0.5 difference. 8 to 10.5 is a 2.5 difference. 13 to 10.5 is a 2.5 difference. 12 to 10.5 is a 1.5 difference. And if you're wondering how I'm doing that so fast, all I'm doing is adding a half to get me like 11, and one more gets me 12, so 1.5. 7 to 10.5, well, I think 7 to 10, that's 3, plus the 0.5, 3.5. 10 to 10.5, that's easy, 0.5. 12 to 10.5 is a difference of 1.5. 11 to 10.5 is a difference of 0.5. Notice I always keep these positive numbers. 9 to 10.5 is 1.5, and then 13 to 10.5 is a difference of 2.5. So, I now have to find the mean of all of these. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Carry the 5. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then I have to divide this by the number in the set, which is 10. 17 divided by 10, just move the decimal one place, is 1.7. So that right there, 1.7, is our mean absolute deviation, our MAD. Okay, what that tells us that each of these numbers on average are 1.7 away from the mean. All right, let's go down and do our last sample. Looks like we got a lot going on here. It says the data set shows the admission prices at several amusement parks. $16, $25, $12, $20, $10, and $25. Find and interpret the range, interquartile range, and the mean absolute deviation of the data. Whew, it's a lot of work there. So, if I want to find the range, well, I'm going to start by, since we're doing range and interquartile range, I'm going to put all these numbers in order from least to greatest because I know that'll be helpful. So, my smallest number is 10. And then we have 12. Then we have 16. Then a 20. And two 25s. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I got them all. All right, let's start. Let's go ahead and find and interpret the range. Okay, so the range is just the difference from the biggest to the smallest. That's easy. So our range, I'm going to write it over here so I have some room. Our range, 25 minus 10 is $15. And to interpret it, what that means is there's a difference of $15 from the smallest to, or from the least to the most expensive amusement park. All right, interquartile range. Remember, that's when we did that box and whisker plot. So basically, we have to find the median, and the median, since there's 6 numbers in the set, falls in between 16 and 20. So our median would be 18. 18 is right in the middle of 16 and 20. And then our interquartile range, so we have to find our first quartile and our third quartile. This is pretty easy because there's odd number in each of these. So our quartiles, you're just finding the median or the middle number of the lower half, which is going to be 12. The median of the upper half, that's our third quartile, would be 25. So that's our middle number there. Those are our 2 middle numbers. So our interquartile range means the difference between the quartiles. So we just take 25 minus 12, and so our IQR, we'll write it over here, IQR, that means interquartile range, is 25 minus 12, which is $13. Now, mean absolute deviation. So, I'm going to erase this here so I can have some non-messy work. And first, for interquartile range, remember we have to find the, for mean absolute deviation, we have to find the mean of this data. So I'm going to start by adding all this up. Let's see, 2 and 6, 8, and that makes 10, 18. Carry the 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10.8, and I have to now divide that by the number in the set. I'm going to break out a calculator, speed things up. 108 divided by 6 equals 18. So 18 is our mean. So to find our mean absolute deviation, we have to find out how much each of these deviates from our mean. So 10 is 8 away from 18. 12 is 6 away from 18. 16 is 2 away from 18. 20 is 2 away from 18. 25 is 7 away from 18. And this is also 7. So now we have to find the average of these numbers. So 8 and 6 is 14, 15, 16, 17, 18, 25, 32. So this adds up to 32. Divide that by 6. 32 divided by 6. Oh, great. We end up with 5.3 repeating. Well, I guess it doesn't matter. I used a calculator, by the way. 5.3 repeating. That is our mean absolute deviation, also known as the MAD. That means each of these numbers, on average, is 5.3 away from the mean, which looks, makes sense because you look at 10 to 18, it's 8 away. So that's the average is 5.3, where some of these are only, 2 away. All right, that's a lot to take in. That's all we have for today.